Hi, welcome to my video presentation of the implementation of VBLAST detection technique. Through this presentation, I'm going to talk about my project in wireless communication. I'm Varun Khandelwal, graduate student at the University of Florida. Before I start, I would like to thank Dr. Dapeng Wu, the course instructor of EEL6509 Wireless Communication System, for giving me the opportunity to study in depth about VBLAST detection and work on a project for the realization of very high data rates over rich scattering wireless MIMO channels using VBLAST detection algorithm. Through this presentation, I will first give a brief introduction to MIMO and VBLAST technique. I will discuss about the various detection technique which are used in VBLAST implementation, which are zero forcing, minimum mean square error, maximum likelihood, minimum mean square error, and zero forcing with OSEC. Following which, we will go through the simulation results which were obtained during MATLAB simulation. I will also discuss the algorithm used by each technique and discuss the inferences which were deduced from the simulation results, and finally state my conclusion. To begin with MIMO and VBLAST, we must understand first the current wireless communication market and its demand. Since the last few years, we have seen a very high increase in the mobile devices like cell phones, tablets, and laptops. These devices put forward a huge demand for better quality of communication and high-speed internet. In this world of 4G, imagine your frustration even if you get 3G data rates on your cell phones at any time. We want seamless data at all times and good quality of communication, which should have high capacity of wireless protocols. Today's standards lie with LTE and HSPA plus services, which have theoretical speeds of over 100 Mbps. So what is the solution to such unprecedented demands? MIMO is one solution. It stands for multiple input, multiple output. It was invented in 1970 by A.R. Kane and D.A. George, and essentially it makes use of efficient multiple antennas at transmission and receiver end, and is used in OFDM, LTE, HSPA, and also in non-wireless communication like ITU-T G9963. Its major advantages is that it provides improved spectral efficiency, improved diversity gain, and increased throughput. Moving forward to VBLAST. VBLAST is one of the implementation of single users MIMO system. It stands for vertical Bell Lab layered space-time and uses spatial multiplexing. In 1996, Gerard J. Fossany developed this transceiver architecture at Bell Labs, which works on the principle of detecting the most powerful signal. From this, it estimates the next most powerful signal to eventually regenerate the received signal. One of the major advantages is that it removes the interference in the signal due to random objects in the channel. In a realistic model of wireless system, random objects in the environment causes radio waves to scatter and bounce randomly instead of simplistic propagation between the transmitter and the receiver antenna. This phenomenon of bouncing and scattering is called multipath, as due to this there is creation of multiple copies of the signal received at the receiver. As destructive interference of the received signal can result in the nullification of the signal by itself, the images of these signals are slightly different from each other in terms of arrival time. VBLAST makes use of this multipath effectively to convert the disadvantage to its advantage, to obtain very high data rates and very high capacity of theoretical values of Shannon capacity of up to 90%. The VBLAST algorithm depends on initialization followed by iteration to begin the matrix based on the transmitter and the receiver antenna is calculated. The next, we find the diagonal entry in the matrix. This is used to update the channel matrix. Using successive interference cancellation, the possible solution is reduced to the minimum and detect the vector nearest to the received data vector to obtain the set of reduced possible solutions. Coming to the detection technique used in VBLAST, let us first talk about zero forcing. Zero forcing is one of the most basic implementation of detection technique in VBLAST. It applies the inverse of the channel frequency to the received signal to restore the signal after the channel interference. Its advantages is that it reduces inter-symbol interference. The next detection algorithm which I implemented was minimum mean square error. It estimates the minimum of the mean square error or MSE of the fitted values of a dependent variable to obtain the decoded symbol. Its advantages is that it reduces ISI while also reducing noise in the received signal due to signal propagation. Maximum likelihood is the best performer detection technique. It reduces bit error rate and vector decoding and also removes the limitation of VBLAST implementation which suffers due to the worst sub-channel in the system. But the problem with maximum likelihood is that it is highly complex and is very difficult to implement. The last couple of detection algorithm is the use of ordered successive interference cancellation with zero forcing and minimum mean square error technique. Since ZF and MMSE has no optimal detection order for minimization of the propagation errors from one step of detection to the next, this technique solves the problem. It helps in detecting the maximum possible order of diversity and gives the best performance when compared to other conventional detection technique in VBLAST. As the part of the project, complete VBLAST algorithm was implemented in MATLAB. The code was submitted along with the rest of the project submission. The different techniques used for detection in VBLAST were tested with different modulation techniques like BPSK, QPSK, 8 QAM and 16 QAM, and a comparative study of all these simulations has been done and shown in the following slides. Let us now discuss the simulation results which were obtained during the MATLAB simulation. In this first slide, we will see the performance results of BPSK modulation of VBLAST when using detection technique like zero forcing and MMSE. The right side graph shows the 8x8 and 4x4 MIMO system performance with zero forcing, while the left side shows the 4x4 and 8x8 MIMO system performance with MMSE. As it is evident, the performance increases as the order of the MIMO system increases, although the improvement in zero forcing is very less when compared to MMSE. The same VBLAST technique was compared using QPSK modulation. While the right side shows the zero forcing across 2x2 and 4x4 MIMO system, the left side shows the MMSE detection technique using 2x2 and 4x4 MIMO system. Even here we see an improvement in performance as the order of the MIMO system increases. These three graphs in this slide shows the comparison between the different detection technique for a 2x2 comparison. The first slide shows the 16 QAM results when it is used across a 2x2 configuration. We compare the result of zero forcing, MMSE with OSIC and zero forcing with OSIC. While MMSE with OSIC shows the best performance, zero forcing shows the worst. In this graph we see the comparison across 8 QAM, while the lower graph shows the comparison while using QPSK modulation. Out here we also plot maximum likelihood, and we see that the performance of maximum likelihood is best when compared to all other detection techniques. These two graphs here shows the performance for a 4x4 configuration, which shows similar trends, where zero forcing with OSIC and MMSE with OSIC show the best performance, while zero forcing and MMSE alone show bad performance when compared to others. MMSE with OSIC shows a better performance when compared to zero forcing with OSIC. So what do we infer from these simulation results? First, zero forcing shows a very small improvement in the bit error rate, while MMSE shows a significant performance improvement. Compared to BPSK, QPSK shows a lower performance. Maximum likelihood shows the best bit error rate performance, and with OSIC or ordered successive interference cancellation, performance of both MMSE and ZF improved. Zero forcing performance is always lesser when compared to MMSE, regardless of the use of OSIC. With increase in the order of MIMO, the bit error rate performance of a given detection technique improved. In conclusion, zero forcing has the lowest complexity and induces low performance improvement due to suppression of ISI only. MMSE shows improved performance when compared to zero forcing by implementation of ISI and noise suppression. At high signal to noise ratio, MMSE performance comes very close to zero forcing detection. With OSIC, zero forcing and MMSE show performance improvement. This is mainly due to the fact that ISI and noise increase trade-off is achievable by OSIC. Maximum likelihood has a very high complexity and is difficult to implement, but yet it has very high performance. This concludes my presentation on VBLAST techniques. If you have any question regarding my presentation or have a doubt on VBLAST implementation, please feel free to email me at khvaran@ufl.edu or post a comment to this video. I hope this video was informative and I was able to help all who are seeking to understand VBLAST technique. Thank you.